Welcome to the Python Learn Together, Code Together. In this session, we will see some of the basic array operations and maximum, minimum, and some random integers, how to generate the random arrays, and some of the other important functions. Okay. So for that, first of all, I'm going to open the Python interpreter. And here, okay, first we will learn some of the basic operations like addition, subtractions, multiplication, all those things that we already know. But for example, a equals to np. Okay, first of all, I need to import numpy and numpy as np, and a equals to np dot array. Here we need to mention the array, so 1 comma 2 comma 3 comma 4, but I'm going to define now two-dimensional arrays. So yeah, here I need to do 1, and okay, now it is the two-dimensional array because the two nested lists are there, and here 1 comma 2 comma 3, and here 4 comma 5 comma 6. Okay, now this is called as the two-dimensional array, and I'm going to define the another array, b. Okay, b equals to np dot array, and here I'm going to use 2 2 comma 4 comma 6 and 8 4 and 2, like this. I'm going to create the two arrays. Okay, now if we just type a plus b, then we'll get the array which consists of the sum of the a and the b. A is this and b is this, and if we do the sum 2 plus 1, that means each element, it will going to add up the each element. And in the similar way, a minus b, that is the subtraction operation, you will get a minus b, and similarly b minus a, anything we can do. Okay, it will going to subtract each elements by elements, and even we can multiply the array, but multiplication follows that multiplication rule of the matrices. If we are in the matrices now, I think a star b, a star b. Okay, now we get 3 ones, or a and b, 1 2 is 2, 2 4 is 8, like this, the multiplication. And even we can do the division, a divided by b, then we'll get the matrix. Now it is the matrix, since we are discussing in the two dimension, so we will get the matrix which consists of the answer of a divided by b. And in the similar way, we can even find the sum of the elements in the array. Okay, for example, if I'm going to define now c equals to np dot array, and here I'm going to define my array as 1 comma 2 comma 3 comma 6 comma 8. Okay, this is my array, and 10. Now you can see that c, and now if I want to calculate the sum of the all the elements in this array, sum of the all these elements, 1 plus 2 plus 3, like that, then I can just use my array is c array name dot sum, array name dot sum. Okay, when we type like this will returns the sum of the all the elements inside this array. 10 plus 8 18, plus 2 is 20, and 26, and 3 plus 1 4, so it gives us the 30, like that. And even we can get for example, now I have this two-dimensional array. Now if I want to find the sum of the elements which are in this first row, then I can just use like what's that, my array is a dot sum, and here if I just type like this, then it will give us the sum of the all the elements. But if I want to calculate particularly this row, then I can just provide here the axis axis equals to 0 means like horizontal, and 1 means in this direction. Okay, axis equals to 0. Then you can see array of 5 7 9, that means it is like 4 1 5, and okay, 4 plus 1 5, and 5 plus 2, that is 7, and 6 plus 3, that is 9. That means now we added like this, that means it's like x is equal to 0 means we are getting the one single um, array here, that means a one dimensional array that consists of some of the all the like these columns, and even we can give even x is equals to 1. At that time it is the exact reverse operation. We get yeah, 6 comma 15, that means like this it will going to add all these things, 3 2 plus 1, that is 6, and this one, that is 15. Like this we can get even the sum, that means the column sum of the row, or the sum of the columns, okay, in 2 dimension. And then comes the broadcasting. Broadcasting means it is called as the multiplication of the any array or anything with the constant number. For example, I have the array like this, a equals to, yeah, this is my array. Now if I just do a star 3, that means each element of this matrix is get multiplied by the 3. So now you can see 3 6 9 12 15, so 1 into 3, and 2 into 3, 3 into 3, like that. So this is called as the broadcasting. Okay, then broadcasting means it's just like here we are going to have a one array, then that into some constant. Okay, that's called as simply like it's like a multiplication of any matrices with a scalar quantity, like that. And even we can find even the maximum number or minimum number in all these elements. For example, now I have the a, this is my array. If I want to find the which is the maximum element in this array, then I can just use a dot max, and here yeah, a dot max, then you can see 6 is the maximum number. And similarly a dot min, a dot minimum, it will going to give us the minimum number in this array. And yeah, I think you understand how to make the sum of all these things, how to get the sum. And even if I want to check the maximum in these 3, then I can just call this as okay, what I have to call a dot minimum, and x is equals to x is equals to 0. Check like that. A dot minimum, x is equal to 0, that means it returns 1 2 3. That means when we compare these two x's, then which x is that means which is the minimum, that it will return like that. So if I just use x is equals to 1, then you can see 1 comma 4 here, which is the minimum, that it will going to return 1 comma 4, that is 5, and 5 plus 2 is 7, and here 6 plus 3 is 9, so it will return 1 comma 4. It's like a column matrix, like array of 1 comma 4. So it will return a dot minimum x is equals to 1. In this way also we can get and yeah, next one is in order to generate the random numbers, we can just use np dot random. Random is the, that means in this np module, this random dot random, this is the function that will going to generate the random numbers. If I call np.random, and here I need to give how many elements the array that has to contain. For example, if I write 4, then you can see it will return us the array which consists of the 4 numbers, and yeah, those are all the random. It's generated randomly. You can just type another time, it will generate different numbers. From that you can conclude that it's generating some random numbers. And we can even find yeah, if we assign this to some for example a equals to no, I'm going to use d equals to like this, then I can just find d dot min. Yeah, if we check the d, it is like this, and d dot minimum is yeah, this value 1 point, yeah, this value, so it gives that minimum. And similarly we can check its sum and all those things. That's already discussed, how to find sum and all. And even we can generate the here you can see it is the floating point number. But if you want to generate some random numbers, that means integers, then we can use another technique called np. Okay, I'm going to use e equals to np dot random np dot random dot okay, and np dot random dot randint, randint. This is the function that will going to generate the random integers. And here I need to specify how many integers I want. That means it's a maximum limit. For example, 6. That means till within 6, from 0 to 6, it will going to generate the random integers. And I have to mention its size, because yeah, that's also the parameter. So size equals to, okay, size equals to yeah, and here if I want okay, I'm going to write 2. Now if you check the e, you can see 0 1. That means until 6 is the greatest, it will generate some random integers from 0 to 6. Okay, some random integers. And size equal to 2 means it will going to generate the 2 numbers. Okay, if I just type size equals to 6, then we can see we can get e equals to 555430, like this. Okay, I think to understand this, and even we can just type 4,4. we will check what it will give. E. Now you can see this is the dimension. We can even create the 2-dimension or any multi-dimension by using this. We'll check. Yeah, I think you understand here. It can generate up to the numbers from 0 to 6 and the size 4,4. That means it has to generate the it is the first dimension, it is the second dimension, so it has to generate the elements, 4 elements in first dimension and 4 elements in the second dimension, like that. For example, if I have 4, 6, 2, then if I check the e, yeah, it generated many values. It is in multi-dimension, that means it's in 3 dimension. You can see that now 4, 6, 3, yeah, you can see that it is going to generate all these numbers. It is very fastest. Okay, and next thing is the unique. Okay, for example, I have a equals to I'm going to np dot array. Here I'm going to write some one dimension, 1, 2, 2, 3, 2, 4, 5, 4, 7, 8, 8, 10. My array is like this. Okay, you can see this. Okay, now if I want the unique numbers from this array, then I can just use the function called np dot unique, unique, np dot unique, and here a. This will going to return us the unique numbers in this. Here you can see 1, 2, and this 2 is repeated, so it is not unique. So 2 is only one time, and 3 is, yeah, I think you understand about this unique. And for example, if you want, along with this here only the unique numbers are there. If you want the index of these unique numbers, for example, this 1 is from this 0th index, and 2 is from 1th index, and this 3 is from 0, 1, 2, 3's index, and 4 is from 5th index, and 5 is from just index. If you want the index of the unique numbers, okay, that we can get by using okay, here I'm going to a comma b. Okay, because we need not a comma b, we will use c comma d. That means we use 2 variables in order to store this one, and as well as this array, and as well as the another array which consists of the index values. So we'll check whether it will give or not. I have to write np dot unique, QUE, np dot unique, and here a comma, and return index, return underscore index, return index equals to true, true. This we need to write. Now if we check the value of C, just remember here A means it will just going to the unique elements to the C, that means my array variable C, and its index equals to true. This is the parameter that means some additional parameters, and it is not compulsory, it takes default value. If we not write this, it default is false. Okay, then here you can see the D. If we print the D, yeah, C is the same thing. This is the 1 2 3 4 what we observed here, 1 2 3 4 5 7 8 10. And if you print the D, we can see it is 0 1 3 5 6 8 9 11. That means this 1 is in the 0th index, this 2 is in 1th index, 3 is in 3, 4 is in 5, 5 is in 6, and 7 is in 8th index. We can see here this 7 lies in 8th index, 0 1 2 3 4 5 6 7 8. So it will return us the index values of these unique numbers. And even we can count how many times this is repeated. For example, here 2, how many times this 2 is repeated. If we have the large arrays, then we can just use np dot, yeah, same thing, just like np dot unique, and here instead of return index we need to just type return counts. Okay, return counts equals to true. Now if we check, the C is same thing, and D is like yeah, 1 is repeated 1 times and 2 is repeated 3 times. Here you can see 2 2 and 2, so it is repeated 3 times. Like this we can get the repeated numbers. Okay, repeated numbers like this, how many times the number is repeated, all these things we can get like this. And even we can another important thing is that we can even find the transpose of the matrix. For example, I have A equals to, I'm going to yeah, 2 dimension. Yeah, it is the 2 dimension. Okay, I already have B equals to 2 4 6 8 4 2. If I want to find its transpose of the matrix, transpose means interchanging its rows and the columns. If I want to find, then I can just use B. Okay, B dot transpose, POSE, B dot transpose. Then it will give us the transpose of that B matrix. Okay, then okay, and next thing is even we can flip the elements. For example, I have A equals to 1 2. Now if I want these elements in the reverse order, that means I want the first element, that means its element at the 0th index is so 10 and 10 8 8 7, like this in reverse order, then I can just use okay, here and use np dot flip and here yeah, A. Now you can see it will gives us the array 10 8 8 7 4. I think instead of this is also possible. We'll check A dot flip, yeah, no, numpy dot enter object is no attribute flip, so we cannot make directly like this, but we can just we have to write like this. Okay, np dot flip of A. Okay, we need to write like this, np dot flip of A, then it will gives us the flip of that matrix. I think you've understand how to transpose the matrix and how to flip the matrix. And another important things is that reshaping the matrix and even the flattening the multi-dimension into 1 dimension. And that means if I have some 3-dimensional or 4-dimensional matrices, how I can convert that to the single dimension. That is called as the flattening. Flattening means something big is there that I'm going to flat. That means from 4 dimension I'm going to flat that to the single dimension. That's called as the flattening. We already know about the reshaping. It's just like a dot reshape that we need to use. That means in order to change the row and the column, that I already told. How to flatten the matrix. For example, if I have A equals to np dot array, and here I'm going to construct one 4-dimension, no, just a 3-dimensional matrix. So not the matrix, 3-dimensional is not called as a matrix, 3-dimensional array. Okay, so for that this in 1 dimension, and now it is 2 dimension, and inside this I'm going to have this is now 3 dimension. Okay, 1 2 and 3, and here 1 2 and 3. Now this becomes 3 dimension. You can see if I give this like space, then it will you will come to understand how this is the 3 dimension. Okay, this is 1 and here this is 1, yeah, and here I need to fill the elements now. 1 comma 2 comma 3 and 4 comma 5 comma 6, 2 comma 3 comma 4, and here 4 comma 5 comma 6. Any elements you can fill. 2 comma 2 comma 2 and here 4 comma 4 comma 4, and here and to fill 1 comma 1 comma 1 and 1 comma 2 comma 3 and the last 2 comma 4 comma 6. Okay, now this is the 4 dimension. If I check the 8, not the 3 dimension. Okay, now it is the my 3-dimensional array. Then if you want to flatten this to the single dimension, there are the 2 methods. That is the one thing is the flatten. Okay, one thing is the flatten and another is the revel. There are the 2 types of that. 2 types. Okay, in order to flatten the multi-dimensional array into the single dimension, there are 2 methods. That is, one is the flatten and another is the revel. Okay, revel means it is like I already discussed the view concept. Revel is also links to that same. That means it is a reference to the parent array. For example, you will come to now when I show the example. I just use a.ravel, a.revel. Then it will gives us the matrix. Yeah, it will gives us the not the matrix. Matrix means 2 dimension. Okay, sorry, it's the array. It will gives us the array which it's the 1 dimension. That means from this multi-dimension it is converted to the 1 dimension, and this is the, that means these are this one is coming from this one. That means it is same object. This 2 and this 2 has the same object. If I use this revel, for example, if I change the a of yeah, now what I'm going to do means c equals to, I'm going to declare this, that means c equals to a dot revel. I initialized and I equalized this a dot revel, and when I check the now a, you can see a is this one and c is this one. Okay, we may think that these 2 are different, completely different, but they are from the same object since we use this revel. For example, now if I change the value of c of 3 equals to 100, okay, yeah, 1000, c of 3 equal to 1000, then if I check the c, it is 1000, it is changed. But similarly it will going to change the parent also. Just think this is the child. Okay, this is the child, c of 3, c is the child of a. Okay, now I change in this child, but that will going to alter even the parent also when we use the revel. That means both are from the same object, both are from the same box. That's why it is giving like this. Another method of making the flattening is by using flatten. And now I have a equals to, yeah, this is my a. Okay, the array, multi-dimensional array a. Now if I use c equals to a dot flatten, 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 then you can see now also the c is the 1-dimensional array, and now I'm going to change the c of 3 equals to 2000. Then you can see now in the c, when I print the c, it is changed, it is 2000, but when I print the a, it is 1000. That means it will not going to alter that parent. That means this child and this parent are different. Okay, this child and this parent are different here. But in that previous thing, when we use the revel, that time the parent is here and the child is here, both are same. That means both uses the same object, but here they are the different. So it will just make the copy of that, but here it is little bit like memory consumption is more. When we use this flatten, it will going to consume more memory because another copy is created. But when we use the revel technique, when we use the revel, we should take care about that it is going to alter the parent, but it will uses the very less memory. It will just object, it will reference to that same object. I think you've understand about all these functions. Thank you.